Yes, Dr. Swami, I have made you host.
Okay, I'll just start in a minute. So very good evening to all the participants. I'm sorry for the delay of 10 minutes. I will extend the lecture for 10 minutes more. And as requested by many of the participants that the lecture should start little late today. So by default, it is late. I had some other commitment. And so I'm just home and that's why the lecture has been late. But we'll make up for it. So don't worry. Today, as per our plan, we will go by some theory discussion on reliability and validity. Finally, to conclude, and which will be followed by hands-on practice using SPSS software. Firstly, we will do how to perform factor analysis using SPSS, and then it will be followed by testing of reliability as well as validity. Lastly, I have couple of research papers which I think in the first lecture of mine I told you all that there are few research papers and I will discuss those papers if time permits to tell you all that how to proceed if we have to, if we design a tool, if we design a questionnaire, how to go step by step to check for the validity and reliability of the tool, right? We have discussed in the first class only that if time permits, then today itself we will discuss those research papers. Otherwise, I will share them with you. You can also download them from the internet. Just in case you are not able to download it from the net, I will share those research papers with you and you can discuss it. Anything which you feel is which you feel should be discussed in today's class and has not been discussed, or which you feel is important for you all to understand the concept of reliability and validity, please feel free to write it on the chat. I will try to address those queries if time permits. Okay, that is what is my plan. But other than it, if you feel there are any queries or any questions or any other doubt, then please feel free to write it on the chat. Okay. Is my voice clear to everybody? Am I audible to everyone? You can write yes on the chat if I'm audible to everybody. Okay. Yeah. So this was where we had left the last class, where we were discussing about some of the types of reliability and validity. yesterday, where we discussed test, retest, parallel forms, internal consistency, split half, and then in validity, we had discussed construct validity, criterion related validity, and content validity, and face validity. Okay, this was where we stopped yesterday. So going ahead, now internal and external validity, I'm not going to discuss it because it is nothing new. It is just related to what we had discussed already. Coming to one of the most important things that we need to understand before we start analyzing the data or before we start performing, and that is factor analysis. So, first, I will be discussing what is factor analysis. I will try to share some theoretical concepts about factor analysis, why it is used, and how to check validity using factor analysis. And then, as soon as we are complete with the theory portion, I'll immediately open a data set. You people don't, if you people have SPSS software installed, then that's not at all an issue. We can do it simultaneously. I'll share the data here in the chat box with you all. But just in case you don't have SPSS installed, don't worry, just understand the process, write down the steps, and later you all can practice. Okay. Then there is a question from Neeraj which says, do we need to do pilot study in AI experimental study? What do you understand? What do you mean by AI experimental study? Neeraj, if you could please elaborate your question a little bit more, so I'll be able to understand it better. Okay. In the meantime, let us. Okay, there's a question from somebody. Can we install SPSS on Linux? I am not very sure about the Linux operating system. Actually, I have not been using Linux, but maybe you can check it on the SPSS website. If they have a trial version available for Linux, you can do that. Neeraj, I'm not able to understand your question. You can get back to me again with a full question. Satya, I'm not having the data. Nobody has the data right now. Only I have it. Okay, don't worry. I'll share it with you once when we do it, do the hands-on. So right now we are focusing on the theory part. So how many of you, before I start explaining what is factor analysis, let me start in this way. How many of you have heard factor analysis before? If yes, then what do you understand by factor analysis? I mean, suppose if somebody asks a one-line question that what is factor analysis, what are you going to answer? Actually, it is a very important multivariate technique in SPSS. So any idea what do you understand by factor analysis? Okay, very good. Dimensionality reduction, wonderful answer. Actually, your name is written in some other language, so I'm not able to understand and pronounce your name. I only know Hindi and English language. So Ananta Krishna. Okay. It is done to find relationship between different variables. Very nice. Rashi. Uh, Developing a common construct among given group of items. Identify latent variables. Wonderful, Mahima. ये टर्म लेटेंट आप तभी यूज कर सकते हैं जब आपको फैक्टर एनालिसिस के बारे में पढ़ा होगा आपने. Clustering and factorization is different, Ananta, but yes, you can say that. Actually, clustering, instead of clustering, a better word is grouping. Yeah. So we've got many answers, I think, and all the answers are correct. So great job, participants. Now, for all those of you who are listening to this term for the first time, let us try to understand actually what is factor analysis, number one. And number two, what is its role in validity, in testing of validity of an instrument. Right now, I mean, a couple of hours before, there's a workshop that's going on by the Indian Sociological Society, and I also happen to be a resource person in that workshop as well. So I had to take a lecture, and that was followed by a valedictory session. Now, in the valedictory session of that workshop, where I'll tell you, there were about 500 plus participants from across the country, and they were all from, mostly from social sciences background, very few from science, but mostly the participants were from social science background, and many of them had this question regarding tool development, regarding factor analysis, and we were surprised to see that how many participants are aware of the fact that tool development and validation is now so important. Because initially people did not actually realize that tool development can also be a very integral part of your research. But we were so surprised by seeing the responses of the participants. The workshop was not on tool development, it was on SPSS. But many participants had asked these questions, and lastly I told them that we are also having another workshop for a different set of audience that is exclusively focused on tool development. And many participants at that time also asked about factor analysis. So we were very surprised that it, like, despite of being from social sciences, people are aware of the fact that there is some technique called factor analysis which is used as an integral part for tool validation. Okay, why it is used for tool validation and what is factor analysis? To begin in a very simple way, I would like to say that it is a multivariate technique. Now, many of you, since you are from non-statistics background, so first let me explain what exactly is a multivariate technique. Multivariate means when you have like many variables. For example, in statistics, we actually have three types of analysis. It is univariate, bivariate, and multivariate. Univariate means you have one variable. Bivariate means we are dealing with two variables. And when we say multivariate, it means that you have several variables. I hope everybody understands what is a variable. A variable is any particular observation, like any particular column in your data that varies from individual to individual. Suppose we are saying weight. Weight is a variable because it will vary from individual to individual. The questions on happiness, each and every question will have different answer depending on the responders, depending on the participants. You're understanding? This type of technique is known as a multivariate technique, where you have many variables and you have to apply a statistical procedure on those variables. Now, to begin with, let us first understand what factor analysis what factor analysis actually does. Suppose we have many variables and okay, let me start with discussing that. Suppose if we have a data set, or rather a questionnaire that has been developed to assess the happiness index. Okay, and it's a part of a research work, so it's a new questionnaire that has been developed with certain additions, modifications, right? Now, in that questionnaire, suppose we have added 50 questions. because there are several sections which have been used to measure happiness. And in all the sections, there are 5, 6, 10 around questions. So in total, we have 50 questions that are used to assess the happiness index or measure the happiness index. Okay, now when the data, when the interviewer or the researcher has started collecting data, then it seems that questions are repeated. I mean, this is just understanding of the researcher or the person who is collecting data. Many questions seem to be repeated, number one. Number two, the responders are feeling uncomfortable in answering the question. The questionnaire seems to be too long, because when you develop a questionnaire, then it is in a very it's in a very beginning sort of a stage, because not everybody is pro in developing a questionnaire and has done several researches. Many of us are doing research for the first time. Everybody does it for the first time. So at that time you might feel that questionnaire is not. Forget about reliability and validity. Okay, just try to understand what I am explaining. Forget about reliability and validity. Just while performing that pilot study, you felt that you are not getting good responses. The questionnaire is too long, and maybe the questions are repeated, and things like that. Just in case if you come across a situation like this, what is the solution? The solution is to perform factor analysis. Now, what does factor analysis do? Number one thing that factor analysis does is to identify the hidden structure of your data. Or, in other words, I can say that identify latent variables. Latent variables or hidden structure means those variables which are not apparent, not visible during the time of data collection, but the variables are there in the data, they are present, the concepts are present in the data, but you are not able to clearly understand them during the time of data collection or tool development. Okay, that is number one thing. Number two is dimension reduction. Actually, factor analysis and dimension reduction, two words are synonymous. Now, what is dimension reduction? As I said in the beginning, suppose we have designed a questionnaire that has, say, 50 questions. You understand? 50 questions just to assess happiness quotient is way too much. So people might feel that there should be some way or the other by which we can reduce the dimension of the questionnaire. Dimension means you can reduce the number of variables. Instead of 50, what if we use 40 or 30 variables and perform the analysis? Right? Now, a big question is how to decide on those 30 variables. That is, how to decide that which variable are playing a significant role and which variables are not playing a significant role. That you can identify using factor analysis. Very beautifully, this technique lets you identify those variables which are playing a significant role in dimension reduction and those variables which are actually not playing a significant role. How it helps you to identify this, we will understand when we see the results. Okay, as soon as we see the results of factor analysis, you will understand it in a better way, that how it helps you to identify those variables which should not be removed from the questionnaire at any cost, because they are important in understanding the concept that we are interested in studying. So this is one of the major roles why factor analysis is used for tool validation. Actually, there is a combination of two types of factor analysis which is used for tool validation, and that is exploratory factor analysis and confirmatory factor analysis. I am not sure how many of you have actually heard about CFA, but CFA happens to be one step ahead of exploratory factor analysis. SPSS software can be used to perform EFA, but suppose you have to do confirmatory factor analysis, that has to be done using other softwares, like there is a software which is called AMOS, which is used for structural equation modeling. It is actually a very advanced concept, confirmatory factor analysis. Now, some of you might be having this question, that suppose we have a tool, we have checked its reliability, now we have to check the validity. Can we just use EFA and go ahead with validity? The answer is yes, because it is not easy for everybody to perform CFA. Forget about being easy. The software is not available. It is a paid software. You have to pay for it, and it is not readily available in every institute. So even if you are not able to do confirmatory factor analysis, you can just stick to EFA. That also helps you to identify which variable is playing a major role in explaining a particular concept and which variable may be removed. Okay, I hope everybody is understanding what is factor analysis. Now, if you see the third point of my slide, it is written here, factor analysis is an interdependence technique whose primary purpose is to define the underlying structure among the variables in the analysis. Actually, this definition is a complete definition of factor analysis. And I must say, this is a one-line definition of factor analysis. First of all, what is an interdependence technique? Actually, I'm not going into statistics because I don't want to make it difficult for you all. But broadly speaking, all multivariate techniques, you all understand what is a multivariate technique? Where we are dealing with more than two variables, right? All multivariate techniques can be divided into two types. Okay, either dependence or interdependence. If you all are noting it down somewhere, please write it down. All multivariate techniques can be broadly classified into two sections, dependence and interdependence. Dependence means you have Y and you have X. Everybody understands what is Y and X? You have a dependent variable and you have one or more than one independent variable. That is an dependence technique. For example, suppose if I have to perform regression analysis and see that what are the factors which are affecting a person's height. Like there is an adult, what are the factors that are affecting a teenage height? Father's height, mother's height. Okay, then maybe dietary habits, genetic characteristics. Okay, many factors. So this type of a model or this type of a multivariate technique is known as a dependence technique, where you have a dependent variable and you have set of independent. Okay. However, when we talk about factor analysis, it is an interdependence technique. Interdependence means you have set of variables. Okay. The variables are uh, the variables, they like there is no demarcation of dependent and independent. You have set of variables, that is all. So the best example of an interdependence data set could be a questionnaire that you have developed to measure happiness. There are 50 questions, even if there are in sections. You understand? Even if the questions are in sections, still there are set of questions, but you have not defined that which variable is dependent and which variable is independent. This type of a technique is known as interdependence technique, and factor analysis is that type of a multivariate technique. Okay, I hope everybody is understanding. Going ahead, as I already said, that broadly factor analysis can be divided into two sections, exploratory and confirmatory. What is the difference between the two? In exploratory factor analysis, just as the name suggests, it is an exploration. You have a data that has many variables. It helps you to break the dimension, like break it into dimensions, and it also helps you to identify that which variable needs to be uh, included in the data, which variable needs to be excluded from the data, and things like that. Okay, this type is known as exploratory. However, confirmatory factor analysis means that you have already performed EFA. You're understanding? You have already performed EFA. Now you are trying to validate your findings by CFA. It is a kind of validation to what you have already done using EFA. So it is done by hypothesis testing. It is actually theory driven. Theory driven means there is some theory that you have decided on the basis of your EFA, and then you are trying to confirm that theory. So this is the basic difference between EFA and CFA. Okay. Next. So what does factor analysis does? There are set of variables and you try to reduce the dimension of that variable. If we reduce the dimension, somebody has written in the chat that we perform clustering. Actually, we don't, I would not call it as clustering, but yes, I would definitely call it as groups, which is known as factors. Factor analysis tries to group variables. Okay, suppose there are 50 variables. Going by the same example, happiness index, there are 50 variables that you have used. Now, factor will try to create, say, 5 or 6 groups of those 50 variables, where suppose 10 of them will come in the first, 10 similar type. You're understanding? 5 or 6 will come in the second, maybe 9 will come in the third, and so on. So these factors are known as latent variables. And this is how it reduces the dimension. It clubs your variables, similar type of variable, into factors. You can call it as clustering. You can call it as grouping. This is what is the methodology behind factor analysis. We have some questions. Please explain this again. Okay, Khushi, I'll do that. Suppose you have 50 questions in your scale that you have developed to measure what is the happiness index. Okay. Now you feel that the questionnaire is too long, you are not getting proper response, the responders are feeling bored. You need to reduce the questionnaire, right? Now you will perform factor analysis to reduce it. The result that you get from the factor analysis is number one, which variable is important and which is not. So this will help you in removing all those variables from the questionnaire which are not important, right? And the second thing it does is it create groups of similar type of variables. Like suppose there are in the 50 set questionnaire, there are 20 questions that are focusing just on eating habits, because that can also relate to happiness. So suppose there are 20 questions in that questionnaire which are only focusing on eating habits. So it will club all those 20 questions into one factor. Then suppose there are 10 questions which are only focusing on your sleeping habits. Then it will add all of it in the second section, which it will call as factor 2. Right? Suppose there are a lot of questions that are only focusing on your social life. It will club it into a third factor, which you will call as factor number 3. So it is helping you in identifying the hidden structure. Hidden structure means food bahar aa gaya, sleeping bahar aa gayi. You understand? Social cycle, social networking या social status bahar aa gaya. So this is what factor analysis does. It helps you in identifying the hidden structure. And how it helps you in identifying the hidden structure? By creating groups of variables. I hope you've understood, Khushi. We have other questions also. Paresh, can we do EFA on responses? Of course. We only do EFA on responses. You have to have data to perform exploratory factor analysis. We have a question from Dr. Anupama also that says, can we decide how many factors we need at the end of the analysis? Yes, absolutely correct. While performing factor analysis, the first thing that the software points out is the number of factors. Means 50 questions को 5 ग्रुप में डिवाइड करना है या 4 में करना है या 3 में करना है and so on. Okay. Rashi, ma'am, here variables are different dimensions or it represents statements in the tool. Here variable means statements in the tool. Statement माने questions, items. Okay, ये चीज बहुत क्लियर कर लीजिए आप लोग. I think Rashi has very well pointed. ये confusion बहुत होता है. Please clear this everybody. Here variable means items in the tool and factor means dimensions. Factor means latent variable. Factor means variable which are created from these individual variables. Factors are created from your items. Okay, clear everybody? Should we always check EFA before CFA? Yes, it is advisable. If you are doing confirmatory factor analysis, it is expected that you have done EFA. I did my pilot study and the questions were open-ended, but still the participants answered them in yes or no or in just a single word answer. So, but then how will it be open ended if the participants have answered it in yes or no? And suppose if the participants have answered it in yes or no, then you should not call it as an open ended tool. It has actually become closed ended now. There is one more question from Mohammed Junaid, multivariate analysis in his theory of suicide. Um, okay, I have not read it, so I am not very sure. Okay, I think I've answered all the questions till now, so let us go ahead and see how factor analysis is done. So as I said, it tries to group variables into factors. Now, how is this grouping done? This grouping is actually done using correlation. I am not sure how many of you actually know this concept of correlation and covariance, but this grouping is actually done on the basis of correlation. Correlation between variables. Variables which are highly related will form, yeah, I can say that variables which are related to each other will be a part of one factor. Okay, this thing should be kept in mind that here grouping is done on the basis of correlation. How is factor analysis different from PCA? It's a very good question, but you've asked it little early. Please wait for maybe 5 minutes more, and then you will get the answer to your question. Okay. Now, why use factor? I think it is clear to everybody why use factor. We all know when we have to group the variables and when we have to find out which variable is playing a significant role in explaining any concept. What are the requirements for factor analysis? Let us read it one by one. Actually, I'm sorry. Actually, these are not requirements. These are kind of assumptions. Now, in assumptions, I'm not sure if I have discussed it before or not, but whenever we do any type of analysis, any statistical analysis, it is extremely, extremely important that we check for the assumption. This thing should be kept in mind, like everybody should keep this in mind, that if you are performing any statistical analysis, assumption checking is the backbone. Nowadays there is AI, there is computer, there are softwares, and because of all this we are actually losing on the basic fundamentals. Data science is trying to overtake statistics, but fundamental building only happens when you study the theoretical concepts in detail. So any analysis that you do, even if you are doing a simple correlation, it is important to see whether your data is actually fulfilling the assumptions or not. Okay, so let us start with what are the basic assumptions for factor analysis. The first is there has to be univariate and multivariate normality within the data. Your data has to be normally distributed. I am not sure how many of you actually know or have heard about normal distribution, but in statistics, normal distribution is supposed to be the base of every analysis. If you people have heard about t-test, then T, ANOVA, all these are performed with the assumption that data follows normal distribution. So for factor also, there has to be normality. Number two, there is absence of univariate and multivariate outliers in the data. There should be no outliers present in the data. Now, I am not sure how many of you actually understand what is an outlier. uh, whenever there are certain data values that perform different from the rest of the data, those are known as outliers. Like, for example, if I ask you all to write down your height, there will be like, since every all of us belong to the Asian subcontinent, so here people are not very tall. So probably the height would vary somewhere between 4'10", 4'11" to maybe 5'9", 5'8", right? Or even 5'7", but okay, let us keep it as at 5'9". But still there will be some of the participants here which will have height maybe 6, 6'2", 6'3", or some of them which might have height say 4'6", 4'7", 4'8". I'm just giving it as an example. Those values are known as outliers. They can be at the lower end, they can be at the upper end, but those values which behave differently from the rest of the data. It is nothing wrong if your data has outliers, but data should be without outlier. It is good if there are no outliers. Okay. Then another assumption is there is a linear relationship between factors and variables when computing correlation. At least three, a factor should have at least three variables. Later on, when we will make factor, the assumption is that one factor should have at least three variables. If three variables are not there in a factor, there is no point in performing factor analysis. Then, second last assumption is variable selection and measurement issues. Many of you are asking this question that can we perform it on a Likert scale? Can we perform it on a nominal scale? Yes. Actually, with some modifications, there are certain methods by which you can perform factor analysis, even for Likert scale data or even for non-metric, that is nominal data. So yes, ideally you should perform it on a metric scale data, but even if you have a Likert scale ordinal or categorical, that is 0, 1, still you can perform factor analysis. The last assumption is very important, and this is where most of the problem lies. The observations should be at least 15 to 20 times of the number of variables, which means suppose you have 50 variables in your tool, you should at least have 500 to 600 observations. Now, this is where most of the people have an issue, because since it is a part of a pilot study, and normally in pilot study, why would we take 600 sample? You understand? अगर 600 ही लेना है तो पूरी data analysis ना कर लें. So why would anybody take 600 observations just for a simple pilot study? So this is where the issue lies. But having said that, at least you should have 100 observations if you are thinking of performing factor analysis, even if it is a pilot study. Nothing less than 100 observations would justify your multivariate analysis. Okay, I hope the assumptions are clear. Do we have any questions? Yes, we have. Every time I see the chat, I can see set of questions. Very good. You people write so much. आप लोग लिखते हैं या सुनते भी हैं हमें? Doctor in sociology, PhD scholar. Acha, that's why I've read that. Okay, great. Shapiro-Wilks or Kolmogorov. Very good, Dr. Anupma. These are some of the tests which are used for normality checking. Rashi, when we frame statements for tool, then we have to design in such a way that they are interrelated and in a specific order under different dimensions. Is that so? as after doing EFA, we will be able to arrange the statements in order, even if they are not. Absolutely correct. Wonderful. Now you know why you have to do EFA. Great. Will not be more than 7 on average. This I have not understood. Can we perform factor analysis for nominal or ordinal data if we want multivariate normality? Multivariate normality, Asmita, you will check only when you have metric data. There is no point of checking for normality in case of, it's a good question which everybody should listen. In case of nominal or ordinal data, there is no point in checking for normality. It is baseless. Checking for normality only holds when you have metric data. Okay? We read outlier, I think cause outliers change the mean value. Yes, they do. I have seen mostly people doing factor on Likert data. In this case, how to check for normality? Creating dummy like 1 to 5 is enough. Actually, 1 to 5 itself is a Likert data, and for Likert, there is no need to check for normality. If questionnaire has closed and open-ended questions, the responses to open-ended question giving new variable will be considered as outlier. No, there is no concept of identifying outlier for an open-ended questionnaire. Every response is a response and no response is an outlier. So for open-ended questionnaire, there is no way by which you can identify outlier. You can create word clouds, you can create like just simple distributions, and that might help you in identifying responses which are different from the others. Maybe that could be called as an outlier, but the concept of outlier mainly relates with quantitative data. Okay, Paresh. In case of Likert scale data, we need to skip the normality. Yes. What kind of modifications we have to make in nominal or ordinal scale to perform factor? No modifications at all. I'll show you, Asmita, I'll show this to you on SPSS. There are different options by which we can perform factor in nominal as well as ordinal scale data. Okay, Rashi. Actually, one of the experts advised me to arrange statements in order. That's why I asked, should I arrange the statements in order before doing pilot? You can arrange it in order and perform pilot and then perform factor, which will help you in maybe rechecking your order. You can definitely order it based on the literature review and all. But after you've ordered it, then you can perform, like collect data, perform pilot and perform factor, which will help you in sort of confirming, like it will help you to confirm that whether your ordering is correct or not. So these are same assumptions only which we have written there. I've just, yeah. So there are two new words which you can see here. No perfect multicollinearity and homoscedasticity. अभी ये थोड़ा ज़्यादा हो गया stats, लेकिन I'll try to stick to very basics. What do you understand by multicollinearity? I saw in the first class that we had some statistics students. So थोड़ा हमारा काम करें and let me know what do you understand by multicollinearity. Let us first discuss about multicollinearity and then we move on to homoscedasticity. Nobody has the answer. Multiple correlation. Very good. Relationship between variables. Independent variables should not be highly. Very good answer, Sunny. That's the perfect answer. The independent variables should not be highly correlated. Actually, हमारे केस में independent है नहीं, we just have variables. So no perfect multicollinearity means the variables should not be highly correlated. They will definitely be correlated if your tool is there to find that whether there is like happiness, what is the happiness index. So questions will be related to each other. You cannot ask one question about happiness and the other about your eating habits or something like that. So there has to be some relationship, but the relationship should not be perfect. This is multicollinearity, and this is checked using the software. Yes, you are absolutely correct, Dr. Rahul. Correlation matrix helps in finding it out. There are other ways by which we can also find it out, so we'll check it when we do it. Homoscedasticity means equal variance. Yes. Homoscedasticity here means that the actually in factor analysis, we don't require that there should be equal variance. So this is an additional brownie point that we get for factor, that it is not important that we have, yes, we have constant variance. Okay. Then linearity assumption, everybody I think understands what is linearity. There has to be linear relationship because we work on correlation. Interval data means metric scale, and adequate sample size means the sample size should be just adequate. It should be appropriate. We have a question. Okay, yes. Homogeneity is similar to ANOVA. हाँ, बिल्कुल. वही वाला homogeneity of variance है, which we do it when we check for ANOVA. Now, these are some of the tests which are performed in SPSS when we actually do it. I am not going to discuss it right now. I am going to skip these two slides because when we do it on SPSS, we'll discuss it then. Now we had a question that what is PCA? Actually, PCA is a method to perform factor analysis. Many people use these two terms synonymously. They should not be used synonymously. There is a difference between factor analysis and PCA. Factor analysis is a bigger cloud, is a bigger umbrella, and PCA is a part of that bigger umbrella. Factor analysis is India and PCA is Uttar Pradesh. So it is just a way to perform factor analysis, and it is the most commonly used method to perform factor analysis. Okay, in PCA only, we try to use the concept of correlation to club the variables together. These are some of the methods by which we do it on SPSS, so I'm not going to discuss it. Let me skip to the part. Yes, these are the two research papers. You people can take the screenshot. Both these research papers are available on Google. Wonderful research papers. One of it is published in BMC Cardiovascular Disorders. It's a very nice journal. The other is not published in a very good journal, but it is a great article. To understand how reliability and validity of a tool is established, you should read these two papers. And trust me, if you download these papers and if you go through it, all the 3 days of my lecture would be clear to everybody. So please try to download it, and when you have free time, when you are just scrolling through Facebook or Instagram or social networking, please give some time and try to download these two papers. You can download them from Google, and here Cohen's kappa is used, Cronbach alpha is used, test retest method is used, factor analysis is used, and they have explained it very well. In fact, in the first paper, Hudar Richardson 20 formula is also used. So you can use it. You can like first learn it and then use it for your own research. These are some of the books which I would advise you all to download. Actually, the first one you will not be able to download because it is from CRC Press, and till now we don't have a PDF version of the book available. But for the other two books, yes, you can get a PDF version. And suppose if you have funds in your institute or university or library, you can recommend them to buy these books. And here we don't have much statistics. Even in the first one, though it is written by a wonderful biostatistician, is still in the first book also, it is written in a way that it can help people from non-statistics background. All the three books, they don't have very detailed statistics. And the three books are wonderful to understand the concepts of reliability and validity of a tool. So just in case you people have a scope, please try to download them or purchase for your institution. They will help you to understand these concepts in detail. Okay. So that is all from my side about the theory part. Before we start it on SPSS, do we have any questions? Kindly explain homoscedasticity again. Okay. Actually, homoscedasticity means that the group should have equal variances. Now, for factor analysis, what is equal variance? What is group? Group means the factors that are created. So ideally, whenever we perform multivariate, there is an assumption that groups should have equal variance. But for factor, there is no such assumption. So homoscedasticity assumption can be ignored. Okay. Now give me a couple of minutes, everybody, so that I am able to share the data with you all. How many of you can do it on SPSS? कितने ऐसे लोग हैं जो इसको SPSS पे कर सकते हैं? ये पर्सनालिटी का डेटा है. Let me try to share it with everybody. Okay, one answer I've got. Two also, very nice. क्या बात. अभी कर सकते हैं तो आप इस डेटा को डाउनलोड कर लें और कर लें इसे. आई एम सॉरी फॉर यूजिंग हिंदी. आदत से मजबूर होते हैं हम लोग. I have shared the data in the chat box. Those of you who have SPSS software can actually do it right now. And those of you who don't have, you please write down the steps and all. It will take some time, Priyanka. In the meantime, I can take questions from all of you. You can understand Hindi very good. Many of the people cannot understand Hindi. That is why. Let me also open the data set for you all. Can we use factor analysis for pilot study? That yes, people have used it. Because for questionnaire validation, you have to have like a small sample. You cannot take a big sample and perform factor analysis there. So yes, you can do it for pilot studies also. Is there any particular format to prove that particular questionnaire is validated? No, there is no format. There are tests, there are methods. You perform those methods and then you can say that whether your tool is valid and reliable. Even sample doesn't follow normal distribution. No worries, madam, it's a pilot study. But yes, if your data is on a metric scale and if it is not following normal distribution, then there is a problem. There are missing data points. कहाँ missing है? Where there are missing points? हमारे डेटा में तो नहीं है missing. अच्छा, हाँ मिसिंग है, कोई बात नहीं. Suppose if, okay, I'll answer a question on this thing. Suppose if your data has missing points, okay, the software is going to do the analysis only on those observations which are non-missing, which are valid. SPSS will only perform factor analysis for those observations. So don't worry if the data has missing, okay? Shall I go ahead with doing it on SPSS? If everybody is prepared, if journal asks, is the questionnaire validated, in which format we have to send the report? This is my query. Okay. You have to tell the journal that these are the methods that you have applied for assessing validity, and these are the results. Like suppose if you say that we've used factor analysis, these are the results of factor, we've used Cronbach alpha, this is the value for reliability, and so on. Okay, Khushi is saying, can you please share the data again? अच्छा, कोई और भी share कर सकता है साथ में मेरे? Thank you, Kismat. Thank you so much. We have many participants who are sharing the data. I'm actually very happy with the kind of participants that we have in this workshop. You people are engaged full time in answering and giving responses. Which measuring scale is used? Yes, Asmita, I'll explain each and every part of the data. I'm waiting for everybody to download and to start. I'll explain each and every part of the data set. Oh, itna bada question, Rashi. If there are no standardized tool available for the tool that the researcher has to make, the researcher has taken ideas from theory and various research papers. Where the related tool is available, that is created by particular researcher. Can we provide citation of research paper rather than giving reference of any standardized tool, as no such tool is available separately? Absolutely. Absolutely correct. You can give reference of the research paper. You can cite it even if there is no standardized tool. Thank you so much, Mr. Paresh. So I think everybody seemed to have downloaded the data and opened the data set by now. So let me explain the data first. For those of you who have not been able to do it on SPSS, no issues at all. This is just for demonstration purposes. Later on, whenever you open the software or any time else, you can do it. As of now, just try to understand the concept and also try to write down the steps. Now, this data is actually this questionnaire. This is the real data, by the way. One of my, like in our university, there are many departments and they keep on coming to us for statistical analysis, and then they ask questions. So this is a data from one such collaborative work that we are doing. So here, this is actually based on this is 459 individuals, and this tool is for their personality assessment. It's a Likert scale data. वो तो आपको समझ में आ रहा होगा, 5-point Likert scale है. And if you see the variable view, I am actually not sure how many of you are familiar with the interface of SPSS, पर अभी हम उसको समझाएंगे. It will take lot of time. So we are discussing the data view and variable view. In the variable view, you get an idea about the kind of variables that are there in the data. तो जैसा आप यहाँ पे देख सकते हैं, there are lot of variables, that is talkative, find fault, does a thorough job. Please see the labels. Depressed, original, reserved, helpful, careless, curious, full of energy, forgiving, disorganized. Somebody has, I think, asked a question about procrastination someday. So यहाँ पे procrastination भी होना चाहिए, because that is also a part of the personality. और आजकल ये बहुत हो गया है सबके साथ. इसी क्लास में हुआ था ना procrastination. Actually, there are a lot of online lectures going on right now. So I'm completely confused because of our vacations. There are so many questions, like online classes that are going on, sometime in the morning, sometime in the evening. So I'm confused that whether procrastination thing was discussed in this lecture or some other. Why is everybody thanking Mr. Saha? I don't know. Article 1. Which article? What have you shared? Oh, is it that article? Wow, the article that we were discussing during the class. So fast. Wonderful. Great. मुझे लगा आपको थैंक यू कैसे होने लगा. ठीक है. So yes, in this class only we were discussing about procrastination. So yes, so this is a questionnaire that has been developed to assess the personality of an individual. 459 individuals have been taken as the responders. और सवाल कितने हैं? Let us see. 44 questions. Okay. Now my target is, first of all, to reduce the dimension. That is, can we club these 44 variables into set of factors, which are known as latent factors or hidden factors, number one. And number two, which variables are the ones that are playing a major role in explaining the personality of an individual, and which variables are the ones that are useless, that can be thrown out of the questionnaire. So this is a data on 459 individuals. But suppose if you are doing a pilot study for tool validation, you need not take 459 individuals. You can even go for less number of individuals. ठीक? So let us first understand how we are going to do factor. We'll actually do PCA here. As I said, PCA is a part of factor. So we will do principal component analysis first. So in SPSS, those of you who have used would know, all the analysis that you do is done in the Analyze tab. So go to Analyze, go to Dimension Reduction and click on Factor. Analyze, Dimension Reduction and Factor. As soon as you click here, there is a dialog box that opens up. Any step anybody has doubt, please ask. Now, what are you going to do? I want to reduce the dimension of all these variables. So I am going to put all of them to right. मतलब right side वाले box में. How are you going to put it? Select first variable here, and then you press Shift key and go down and select the last one. I'll repeat it once again. ऐसे हम एक एक करके भी डाल सकते हैं, but that's a cumbersome process. So you select the first one. हाँ बिल्कुल, Control A से भी कर सकते हैं अनंता. Yes. You select the first one. You can either press Control A, or you select the first one, then you go down, press the Shift key, select the last one, and you put all of them to the right. Okay, as soon as you put them to the right, you will now be performing factor analysis on all these variables. Now, how to do it? Click on descriptives. In the descriptives, click on univariate descriptive. Click on KMO and Bartlett's test of sphericity and click on coefficients. Why I am doing this? Please wait for a few minutes and you will understand. As of now, just keep writing. What am I clicking? Univariate descriptives, coefficients, and KMO and Bartlett's test of sphericity. There is a purpose to everything in life. So there is also a purpose to why I am clicking. You'll understand it later. Okay. Linear and limiting. Yes. Okay. I think everybody has done it till here. Let us click on continue and let us go to extraction. Now see, these are different types of methods to do factor analysis. If I keep on discussing each method, it will require two such kind of workshop, means 6 days. 6 days more to discuss each and every factor. Sorry, each and every method. So as of now, we are not discussing these methods in detail. Just to keep it very simple, these methods depend on the type of data that you have. Sometimes some kind of methods are used for nominal scale data. Some methods are better for ordinal. Some are methods for non-normal. Some methods are good for non-normal continuous type of data. So it actually depends on the type of data that you have. Then we decide which method is good. So if you read more about them, you will understand it better. But for this kind of data, which is generally used by everybody, that is ordinal and Likert scale, principal component method happens to be the best one. All right. Then click on scree plot. Again, why I am doing it? You will understand it later. Actually, when something happens in our life, we don't know why it is happening. Sometimes if bad things happen, if things don't go according to our wish, then we blame the Almighty. We keep on saying why something has happened. But later we realize that it has only happened because of our own good. So scree plot also I am clicking because of your own good. Okay, so click on scree plot. Then here eigenvalues, you have to keep it at 1. You don't have to change anything. What is eigenvalue? I'll explain. Don't have to change anything here. Maximum iterations for convergence, 25. What is this and why 25? You'll understand when we run. So as of now, in the extraction section, you just have to click on scree plot. Click on continue. In the rotation section, click on vary max. Again, why rotation? You'll understand. Just click on vary max. Continue. Then scores, you don't need anything. Then in the options, click on nothing. Okay, nothing. So just 3 things you've clicked: descriptive, extraction, and rotation. Should I repeat it once again? In the descriptive section, click on KMO and Bartlett's coefficients and initial solution. In the extraction section, click on scree plot. And in the rotation section, click on vary max. Now click OK and you will get a series of results in SPSS. Actually, my system is little slow, so it is taking some time in running. What is the criteria of minimum sample size estimation before conducting factor? Any thumb rule, like for example, according to my learning, number of items in a given scale is the estimated sample size. However, I've seen clinical sample also, which is 5 times or as minimum as 100. Yes, I agree with what you are saying, Mr. Saha. Absolutely. We should take 100 sample size at least. And normally it is said that it should be 10 times of the number of variables. But suppose for a like a pilot study, suppose you have a data that have variables, say 20 or 30, at least 30 you will have in a tool, right? So suppose you have a tool that has say 30 variables, then how can you have a 300 data? So even if you go in for say 5 times of that, that is 100 would suffice. It's not wrong if you say that it's a pilot study with 100 sample and you have done factor analysis, right? Yes. So just see the number of tables. If data saturation happens in 50 samples, what do you mean by saturation, Paresh? I have not understood. What do you mean by saturation? Repeated responses. Means your questionnaire is not good. Actually, with your question now, I will explain one of the most, I would say, important concept related to factor analysis, that is variability. I think since we started 10 minutes late, so I think I should take up the class till 8:40, everybody, because we need to understand the interpretation of factor, right? So the class would go up to 8:40, 8:45. Is it fine with everybody? We have the last class today anyways, so let us study more and postpone our dinner. But I think, anyways, nowadays people just keep their phone and system on and have dinner, watch TVs, and do everything. So I'm not sure how many of you are seriously listening to my lecture or having your dinner and chilling out on Monday. But, anyways, I'm assuming that you people are listening to what I'm saying. So I think Paresh, going to what Paresh had said, that suppose we are having repeated responses, means suppose we have reached to a saturation level, this means that your data is capturing less variation. Less variation means, like, suppose I'll give you an example to help you understand it better. Suppose there are like 100 responders, and I am asking a question related to their happiness index or happiness quotient. Will it be possible that everybody sort of have the same answers? Suppose there are 100 people, everybody will not have same response. You understand? People will have different responses. They should have different responses rather. So, variation is the key to understanding factor analysis. Your responses should vary. If there is no variation, this means that your tool is unable to capture the concept in a proper way. The tool is not able to capture the data in a proper way. So variation is the key in case of factor analysis, and this we will understand when we proceed. Now let us see the results. The first table happens to be the mean, standard deviation, and the number of observation. Simple descriptive statistics, which is normally used when, like it is normally reported whenever we do any kind of analysis. So first table happens to be descriptive. This is followed by a correlation matrix. Now, somebody had said that to check for multicollinearity, we can create a correlation matrix. Now, this is a correlation matrix. All the diagonal elements are 1 and all the off diagonal elements means elements which are there and elements which are at the lower diagonal, they have the values of correlation coefficient. Now, my question to everybody here is it possible to interpret by looking at this matrix that whether the variables are highly correlated or not? I mean, is it easy to interpret? Yes, exactly, Kismat. This is a very complex type of a matrix. The reason is we have 44 variables. You understand? We have 44 variables, so it is a 44 cross 44 matrix. Some of the variables might be very high in correlation. Some of them might be very low in correlation. So how to decide that which variable should we take for the analysis? How should we go ahead? This decision is done. So this correlation matrix could just be for representation purposes. Normally, people don't add it in the research paper because unnecessary, it will occupy a lot of space, and research papers nowadays have page limitations, table limitations. So unnecessary adding such a huge table won't add to any purpose. But yes, I've seen people adding this up in their thesis. Of course, thesis तो जितना मोटा होगा उतना अच्छा होता है. So people do add it in their thesis, but there's no point actually. This is just for representation purposes. For this only, there is this test which is known as Bartlett's test of sphericity. If you remember, we had checked on this. Now, if you people are aware of testing of hypothesis, you would know that every test, statistical test, has a null hypothesis and it has an alternate hypothesis. Right? Every test has a null and an alternate hypothesis. Here, for Bartlett's test of sphericity, the null hypothesis is there is no correlation. Okay, I'm repeating. Here, in case of Bartlett's test of sphericity, the null hypothesis is there is no correlation. Or in fact, I would say the null hypothesis is correlation matrix is an identity matrix. Can anybody tell me what is an identity matrix? I know it is a bit to mathematics, but I'm sure we have studied, everybody has studied it in the school. So can anybody tell me what is an identity matrix? Nobody? Actually, identity matrix means diagonal elements are 1 and off diagonal elements are 0. Yes. Very good. So identity means diagonal are 1 and off diagonal are 0. Now suppose off diagonal are 0 means there is no correlation. And for factor analysis, there has to be correlation. मल्टीकोलिनियरिटी नहीं होनी चाहिए, but linear relationship तो होनी चाहिए. You understand? There has to be a correlation. So, Bartlett's test of sphericity, here the p-value should be less than 0.05 and it should be rejected. Here the p-value is less than 0.05 and it should be rejected. Means correlation matrix should not be an identity matrix. Only if this assumption holds, you should go ahead with factor analysis. Otherwise, you should stop. Means if this p-value SIG is greater than 0.05, 5 I'm saying at 5% level of significance, if this is greater than 0.05, you should not go ahead with performing factor analysis. Okay? This is one. And the second is KMO, measure of sampling adequacy. This value is 0.841 here. This value lies between 0 and 1. The near this is to 1, the better is your data for factor analysis. Okay? Near it is to 1, better is your data for factor analysis. So we have 0.841 means our data is absolutely perfect for factor analysis. Okay? Next table. These are the extractions. Extraction means how much variation a particular variable is able to explain. Now, in the beginning only, just as Mr. Paresh had asked, that suppose we are getting repeated responses. So I said that having variation is important, right? So here, those variables which have extraction less than 0.5 are actually not contributing in explaining the personality, and they can be removed from the data set. I'm repeating it once again. Those variables that have extraction less than 0.5 are not contributing in explaining the concept of personality, and they can be removed from the data set. So here, if you see, forgiving is having value less than 0.5. और भी कोई है? Do we have any other variable that has less than 0.5? ऐसा लगता तो नहीं है मुझे. क्वेरिल, क्वेरिल है क्या कोई वेरिएबल? अच्छा, स्टार्ट स्क्वेरिल, हाँ, यस करेक्ट. रिग्जिन, और भी कोई है? डिसऑर्गेनाइज्ड, नहीं, फॉरगिविंग, हाँ. Actually, what happens is, suppose you have 44 variables. 2 or 3 are less than 0.5, then you can go ahead. Actually, the data is very good. KMO 0.8 आ रहा है. I mean, this is a good questionnaire actually. Problem वहां आती है where you have 40 variables and 50% have value less than 0.5. There is an issue. Okay, so one way to remove those variables is variables which have value less than 0.5 should be removed from the data. Cross loadings bus now. Yes, Mr. Saha. I think you've done factor analysis before. You'll help me in explaining. Okay. Coming to the next table, which is one of the most important tables. This is known as total variance explain table. Now, first, actually, to explain this table, let us first understand. Here, it is divided into 3 sections. This is first, initial eigenvalues. This is second, extraction sum of square loadings. And this is the third one, rotation sum of square loadings. First, let us understand the first part, that is initial eigenvalue. Now, what is eigenvalue? Eigenvalue actually helps you to understand how much variation is being explained by a particular factor. Now, here the system has created factors corresponding to your variables. So by default, it has created 44 factors. जितने वेरिएबल होते हैं फर्स्ट स्टेप में it creates उतने factors. So here, since we had 44 variables in the data, so here it has created 44 factors, or I can say 44 components. Okay, now we have to decide how much should be the optimum number of components. Like I gave you an example that suppose we have a questionnaire on happiness, 50 questions. Then first step is how to decide that whether we have to club those 50 questions into 5 sections, into 6 sections, into 7 sections, and so on. You understand? So this is one problem, that how to decide that those 50 questions have to be clubbed into how many components. So the rule is eigenvalue has to be more than 1. The variation explained should be more than 1. You're understanding? This was the reason why during the analysis, we had clicked on variation explained more than 1. So here there are 10 factors that have eigenvalue more than 1. So here we will club 44 questions into 10 factors. Okay. First is able to explain 16.545% variation. Always remember, first component explains maximum variation, followed by second, followed by third, and so on. Which means those variables, please understand, those variables which will come in the first component will play the most important role while explaining personality. Because first component is explaining maximum variation, followed by second, followed by third, and so on. I'm explaining this concept once again. By default, the process creates as many components as you have number of variables. So suppose you have 44 variables, it will create 44 components. We have to decide that what is the optimum number of components. To decide that, we see the eigenvalue first thing. See where my cursor is. Those components or those factors that have eigenvalue more than 1, that is an indication of the number of factors that should be taken in a data. So here there are 10. That is why we have decided that we will club 44 questions into 10 factors. Am I clear with everybody? This is the first section of the table. In the second section, they have just copy pasted it. So here we had 10. Here also they have just copy pasted it. So it is the same thing. The third section is important. This indicates rotation. Now remember, I had clicked on vary max rotation, right? What is vary max rotation? Now, as you can see, by default, first component is explaining 16% variation. second is explaining 9.5, then 6.9, and it keeps on decreasing. Now, my objective is, actually rotation means that keeping the total variation fixed, you try to maximize the variation by each of the component. I'm repeating it once again. Keeping the total variation fixed, you try to maximize the variation by each of the component individually. So you cannot change the total. It has to be 58.289. वो यहाँ पे भी 58.289 है. But keeping the total fixed, individual variation you will try to maximize. तो किसी का बढ़ाएंगे तो किसी का तो कम होगा ना. आप समझ रहे हैं? Suppose you are fixing 58.289. So if you will increase one, the other is going to decrease. This is what rotation means. Because, and why at the first place we are doing rotation? Because we want to maximize the variation. And here comes the role of iteration. If you remember in the like when we were doing it, there we had seen 25 iterations for convergence. अब कब तक rotate करेंगे? So we have to make a cutoff for it. That cutoff is done as 25. So we fix it up at 25 iteration. Okay, this is rotation. Now coming to the next table, it is your scree plot. This graphically helps you to identify optimum number of clusters. And how is it interpreted? It is interpreted in the form of an elbow. Elbow पता है सबको? जैसे like when the elbow comes straight, there you see that is an indication of the optimum number of clusters. जहां के बाद further decline नहीं होता, almost constant होता है. But since it is a graph, that is why interpretation is subjective. I might feel 10, somebody might feel 9, somebody will say 7. That is why we take the concept of eigenvalue. So scree plot can just add to the beauty of your research paper and nothing else. Being a statistician, I would say that graph only adds up, final decisions are done by the values. Okay. Coming to the next table, component matrix is not of use because we have done rotation. So now we come to the rotated component matrix. This will help you to identify which variable goes into which component. Because we had two steps, right? First was to decide how many components. That we have decided 10. Now next is, out of those 44 variables, you're understanding which will go into first one, which will go into second one, which will go into third one. That is the next step. And this is decided on the basis of rotated component matrix. So how do we decide it? Please understand, this is the last thing and the most important. The most important. Suppose we see talkative. Out of all these values, ignoring the sign, which component has the maximum value for talkative? Can anybody answer it? Ignoring the sign, just looking at the magnitude, which component has the maximum value for talkative, ignoring the sign? क्या बात? And this is the answer to your question. Talkative goes into second component. Can anybody tell me finds fault goes into which? finds fault किस में जाएगा? Yes, finds fault will go into sixth component. This is exactly how we decide which variable will go into which component. Now let us make it more interesting. Let us do one more thing. Now this is all about factor. The last table is simple correlation and that's of no use. So this is all about factor. Let us make this table more interesting and then we will see the beauty of factor analysis. Go to analyze, same steps, just one more addition. In the option, click on sort by size. हमने पहले इसलिए नहीं किया था because if we give all the gifts to a child at the first place, the child will lose interest. So I wanted to maintain your interest. That's why I did not tick it in the first go. So click on sort by size in the option section and now run it, everybody. All the analysis would be the same except for the last table. I mean, the second last one. Now see. Disorganized, does a thorough job, lazy, careless, efficient, reliable, stick to plan, all similar kind of personality traits have come in the first component. If a person is disorganized, the person would definitely be careless. Now somebody would say efficiency is just opposite of disorganized. Yes, but it relates to one personality trait. So ignore the sign. I mean, you understand, disorganized has value minus 0.7. Efficient has value plus 0.6. So ignore the sign. The trait could be negative or positive, but it is related to one single characteristic. You're understanding? Disorganized, lazy, careless, all of it relates to one personality trait. So they have all come into first component. See the second one, quiet, reserved, shy, talkative. अब आपको ढूंढना नहीं पड़ेगा. Sort by size से उसने अपने आप से sort कर दिया. You're understanding how beautiful is this concept. Now, if a person is quiet, they would definitely be shy. They would definitely be reserved. Talkative is again related to quiet only. I mean, it's an opposite trait. Outgoing, assertive. So all of this come into component 2. This is what is factor analysis. So I hope everybody's understood. Do we have any questions? We have some question. Should we use Kaiser's criteria, that is eigenvalue more than one scree plot or MAPE test to determine number of factors? What if these methods? Exactly. If these methods give conflicting results, it is better. It is Kaiser's criteria happens to be the most relevant one. Can you please explain Barry-Max rotation? Yes, I can. Barry-Max rotation means that we try to maximize the variation explained, keeping the total variation fixed. If you see this table, Khushi, total variation आपका कितना आ रहा है? 50. This is the cumulative variation. So total is 58.289. We are fixing the total, but we are trying to maximize individual variation. Maximize कैसे हुआ? यहां पर आप देख रहे हो वेरिएशन was 2.3, यहाँ पे 2.6 हो गया, कुछ तो बढ़ा ना, यहाँ 2.99 था, यहाँ 4.78 हो गया. So we are trying to maximize individual variation, keeping the total variation fixed. Okay. So all 44 questions have been grouped into 10. At least contributing questions were removed. Is it so, ma'am? All the 44 have been grouped into two. As of now, no questions have been removed, but you know that which are alike, and out of those which are alike, which are the ones that have low extraction and which are the ones that have high extraction. So then you can remove those questions which have low extraction. Okay, Dr. Anupama. What is the need of maximization? Maximization is important because factor analysis is based on the fundamental concept of maximizing variation. There should be maximum variation. Higher the variation, better it is. After creating factor, there is no change how to incorporate this data for further use. You have no change. It has just told you that it has informed you which factors are playing a significant role, which variables are playing a significant role. Now, suppose extraction is low, then you remove that variable from your data and then redo the analysis. So you have to do changes based on the results of factor analysis. Okay, Kismat. I think we have any other questions. So I hope you all had a good time learning about validation and reliability of questionnaire. How can we label factors meaningfully when patterns of is ambiguous or inconsistent? Actually, labeling factor is a task. How to name factors is a task. But generally what happens is we try that we get consistent results that help us in naming. But yes, it does create a problem when we have inconsistent results. Here we are doing EFA and CFA is different. Here we have done exploratory factor analysis. CFA is not done using SPS. So CFA happens to be one step ahead. Yes, it is done using AMOS. So if we have no further questions, then I can end the session. Level of measurement for all tool taken for a thesis, should it be same or it can differ? Ideally, it should be same. But if it is different, then you will have to perform different analysis. Like for different sections, you will have to do it. Because one thing you have to keep in your mind while analyzing, all the variables should be measured on a same scale. So thank you everybody, and hopefully we'll meet sometime. Thank you.
Thank you, Dr. Shambi, for wonderful sessions you have delivered in these 3 days. So, and I'm sure the participants have get benefited from it, and they definitely remember your wonderful sessions and these lively sessions. So, to engaging participants is a very tough job, but I can see that they are well participated. So thank you so much on behalf of our organizing team and on behalf of all the participants. Thank you so much. And participants, you will receive your certificate in this week till Saturday. So thank you all for joining this workshop.
Thank you everybody.
Thank you, Dr. Shampi. Thank you once again. Thank you all.